Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on building energy systems and auditing. In the module number 5, the lecture number 23 will be discussed now. In the lecture 23, we will discuss the envelope transmission value RE/V, which we have already discussed in the lecture number 22. But in this particular lecture, we will see some of the analysis of RE/V and how it will going to actually apply in apartment buildings. So, those we will see. So, we will start with a small problem. So, this is the two layout in the sense of there are two different sizes of the apartment. I have drawn only the perimeter wall. Internal wall will not participate in the RE/V. So, that is immaterial. So, the perimeter wall that has been shown in the these two figure. The left hand side figure envelope are actually is actually adopted for the unit A and unit B, and the right hand side the layout the perimeter layout is applied for the unit C and unit D. So, unit A, B, C, D are placed in a particular floor in an apartment building, and centrally there is a circulation area. Again, the exposed wall in the circulation area also will not going to participate in the RE/V calculation. So, the envelope area which is exposed to outside, those areas of A, B, C and D will going to have its role to play. So, at the cornermost figure in the right hand side, I have shown the layout positions. So, smaller apartment unit A and unit B are in the northern direction, and larger apartment of unit C and unit D are in the southern direction. And I am assuming that height of each floor will be of 3.5 meter. So, even though it is a G plus 5 apartments, only a part of one floor can be calculated for this purpose, because finally it will be repeat for all the 5 floors or so. So, that we will see this particular the apartments are having two type of window W1 and W2. The dimensions are there in the next slide, and also one glazing G, which is mentioned here as a G, and all the dimensions mentioned over here is in meter. So, in the next slide or maybe in the same slide, we have seen a table, and this table shows the width and the height of the windows. So, and also the projections. So, window 1 and window 2 are having same height 1.2 meter, but it has a differential width 1.5 meter for the window 1 and 2 meter for the window 2. Whereas, the glazing is having a higher depth, that is 2 meter depth or height, and it has a width of 2.5 meter. It does not have any projection. The wall thickness at 250 mm, and it has a brick wall of U value of 2.3 watt per meter square degree centigrade. The windows are of 6 mm double glazed window DGW, and the U values are 3.1 and SHGC is 0.8. Those windows are your W1 and W2, and glazing is of 6 mm single glazed window, little higher U value 5.3, and SHGC is also little lower, of course, it is 0.6. So, based on this particular data, we should see what is the RE/V value and whether the value is comply with the climate of Thiruvananthapuram, that is in our warm and humid climate. So, we will see that one. So, now first of all what we have to do is that we have to see we have to collect or we have to note down the factors of orientation. So, in the factors of orientation, it has to taken for the warm and humid climate, because it is in Thiruvananthapuram, which is warm and humid climate. So, A, B and C values are taken as 5.15, 1.31 and 65.21. Now, the orientation factor, see in my proposed the layout, the orientations of all the floors are exactly in the north, east, south and west direction. So, I will have to take the orientation factor from the second list, because latitude of Thiruvananthapuram is less than 23.5 degree north, and all the only the 4 values out of the 8, the north, east, south and west, the orientation factor, the omega factors are noted down as 0.659, 1.155. For south it is 0.966 and for the west it is again 1.156. So, these values will take to our main frame of formulas, which we already seen in the lecture 22. Next, my job is to find out calculate the area, the envelope area. Now, you see in the envelope point of view, let us first find out the areas of the north and south. So, north, if you see the north, in the north we have the A and B, which comes from this particular unit plan. So, it is a mirror image. So, I have written down the total wall area or the length of the wall as 6 plus 4 plus 6 plus 4, that means this is your 6, this is your 4. So, this is your 6 and this is your 4, and again it will be a mirror image. So, this will be your 4 and this will be your 6, right. So, 6 plus 4 and 6 plus 4, and plus there are 2 meters, twice 2 meters, which are actually this is 2 meter and this is 2 meter, comes from this is 2 meter and the mirror image of that one is 2 meters. So, this 2 will come also, because it is also facing north, right. So, and I have multiplied that by 3.5 meter, because 3.5 meter is my h. So, total 84 meter square is my total the north facade area. So, what I did in gist, I have taken the length, whole length of north facade wall, 6 plus 4 and again there are 2 meters, and multiply that with the floor height h is 3.5, that gives me 84. So, that will actually come down to be 84 meter square. So, now we will see some deductions, because we have some kind of the windows. So, how many windows are there in the north facade? Because there are 2 W1. So, this is for your W1 and this is for your W2, and this is the glazing area, there are 2 glazing areas. Okay. So, so W1 and W2s are there, the dimensions. So, W12 how? Because in this particular A, there will be a W1 and there will be a W2 and there will be a glazing, and here will be a glazing, there will be a W2 and there will be a W1. So, there are 2 W1, 2 W2 and 2 glazing. So, by virtue of that I have calculated the areas of the window and the areas of the glazing. So, and finally, I found out the total envelope area minus the window and the glazing area. So, 65.6 meter square is my solid brickwork, and 8.4 meter square is the area of windows, and 10 meter square is the area of the glazing. Similarly, I will calculate for the east and west. So, for east and west, if you see, so these are the 2 east and west side. So, if I say this one has to be your 6 meter, this has to be your 4 meter, and then next C and D are your from the second plan. So, this is your 5 meter and this is your 7 meter. So, it is 6 plus 4, 5 plus 7, and there are 2 meters. So, this is your 2 meter and this is your 2 meter. So, that is also facing east, and I have multiplied with 3.5 meter. So, that gives me the 91 square meter is the envelope area, facade envelope area for the east and west. And please remember, this is a mirror image. So, as it is a mirror image, so the 91 will remain for the east also. So, in this if I now see the how much is the deduction for the windows and the glazing. So, from this particular key plan, so we have 1 W1 over here and 1 W2 over here, and in glazing here there is a glazing, then there are 2 W1 and W1, and there are 2 W2. So, finally, it makes me 3 W1 and 3 W2 and 1 glazing in the east and west facade, and based on that I have calculated the area of the window as 12.6 meter square, area of the glazing at as the 5 meter square. Now, I can find out the solid wall area as 91 minus those area. So, 73.4 meter square is the solid wall area. So, I need those, specifically the fenestration area, two different type of fenestration, because those are having different material, those are having different projections. So, I have to segregate those fenestration into different ways of windows and the glazing and the wall area. So, I will take that to the next slide, and I have made a chart where I have shown the area calculation. So, those if I again go back a bit, so 673.4 and 65.6, those are the solid wall area, 65.6 and 73.4. Let me check once more, 65.6, and yes, and the window areas are 8.4 in the north and south, and 10 are the glazing areas, whereas the window areas in the east and west is 12.6 and 5 meter square is the area of the glazing. And the orientation factors are also mentioned in the east, west, north and south. I have taken already, and I have the U values and the SAGC values are also there. The next what we will do, I will go one by one, and I want to try to make a kind of a chart and calculate the whole the formulas. I will put the right value in the right place. So, first the first part of the equation. So, that part of the equation is for the solid wall. So, the first column or the second column gives me the solid wall area. The corresponding U value is 2.3. There is no change of the U value. There is a orientation factors are there OF, and there is a this 3 multiplication, basically the area of the opaque wall, the U value of the opaque and the orientation factor is multiplied with each other, each line, each orientation, and then it is added up, and that gives me a value of 635.32, this last value. So, I got the summation, but I have to multiply with A, that the climate factor. Similarly, I will go to the second part of the equation, which is the first part or U value part of the fenestration. So, now I have to write down the fenestration area, which are and these fenestration areas are two type. As you know, that first is I have calculated for the windows, which are having 3.1 as U value, and those are the areas of the window 8.4 and 12.6. Again the same orientation factor is taken for all the 4 sides, and it has been multiplied and added up. So, this 132.58 is the product of the window part of U value part or so. But I have still left with another part of the fenestration, which is your the glazing. So, for that the glazing areas 10 and 5 has been taken into the north and south and east and west, and U value has changed. It has a single glazing. So, it is 5.3, same orientation factor is kept for the calculation, and again multiplications and adding up gives me almost about 147.37 is the glazing value. So, now I have to add these two with each other, and then I have to multiply with B. So, that I will do later. These two are the boxes gives me the two separate entity of the fenestration, because there is a change of U value, and next onwards we will see there is a change of the shading factor or so. Now, we have the PF, the projection factor. So, in the problem statement it is given that the windows are having 450 mm projections, and which is your h, this is your h, and divided by the V is the vertical depth of the window, or 1.2 meters. So, that means this is 0.375 is the projection factor, and this is, I have to see the table number 11, which is for latitude less than 23.5 degree, because it is Trivandrum, Thiruvananthapuram. So, I have to go to the right line, or I have to take the row which is giving me the PF within 0.3 to 0.39. So, based on that I have taken the ACF, that is the equivalent shading factor of north, east, south and west, which is 0.86, 0.797 for east, for south it is 0.754 and for west it is 0.796 again. So, these have been taken care of. Now, this particular the shading factor will be used to calculate the equivalent shading coefficient or so. So, we have the 4 orientations. We have the ACF, which is just now we have calculated or obtained from the table number 11. This is for the window, which window is having the unshaded SHGC value of 0.6 given in the problem. So, the SHGC equivalent SHGC equivalent is nothing but, if you remember, if it is nothing but SHGC unshaded by ESF. So, by dividing those ESF with the 0.6, I got the equivalent the factors. Equivalent factors will give me the effect of the projections in that particular windows, and the areas are already there, orientations factors are there. So, now I have to multiply these 3 quantity, the area, the equivalent SHGC, which is this, area is this, and this is the area, this is the equivalent SHGC and the orientation factor. The products are like this, and then I added the product. So, 20.44 is for the windows. Now, if you go to the next, the ESF is 1 for the glazing. Why 1? Because there is no projections, no horizontal shade, it is 0. So, then there is no that kind of reduction will not be there, it will be exactly 1, and the unshaded value will remain as the equivalent one. So, 0.8 will be remain, the areas are 10 and 5, orientation factors are same. So, again multiplication of those 3 things, and that gives me, and added to that will give me 22.24, which is the values of the third part or of my equation, or you may say the second part of the fenestration equation. Now, what we have? We have a single part of the first equation. The second equation or second part of the equation, I have 2 based on the u value of the fenestration, and fenestrations are of 2 type, one is window and one is glazing. And also the third part of the equation also gives me 2, this 20.44 and 22.24, which are the glazing and the window values for SHGC point of view. So, these 2 are those calculation. So, now I have make the total, I have added up. So, this, if you remember, this 653.32 is this value, and 217.95 this is, there are 2 such values if I go back. So, it is actually the sum of 132.58 and 147.637. So, these 2 added together gives me 279.95, whereas The third one is the third part of the equation. So, this part of the equation is also comes from the addition of 20.44 and 22.24, that gives me 42.69, and the A, B, C values are respective the row wise it has been mentioned, and that is multiplied to each other and added up to each other, and the residential transmission values is calculated based on how this. So, these three are added, these threes are added. So, I can write plus, and this is equal to this is this. Now, how I got 18.35? 18.35 is this 6,422 are this big third bracket value, and this RETV will be now this 6,422.27 divided by the envelope area. The envelope area is 350. It includes the all the areas, the wall area and the window area, fenestration areas and all, and that gives me 18 point, which is much higher, 35 watt per meter square. Its the unit is watt per meter square. So, I must write here watt per meter square, which is very high, which is higher than 15 watt per meter square, which is permissible. So, this design is not good. This design is not good. You have to reduce this value to 15 or less than 15. Not good in the sense from the envelope, the heat gain point of view in the warm and humid climate. So, how can I decrease this from 18 to 15 or little less than 15? I cannot change the areas. So, I have to go for some improvised version of the material. So, I have to insulate the wall, or maybe I can go with some more chhajja to get benefit from the SEF, or maybe I can use some other type of glazing material which will give me less amount of U value or less amount of SCGC value. So, as simple as that. So, there may be one question that why I have taken, it is G plus 5 building, but why I have taken only one floor 3.5 meter in my calculation, because whenever I go up another floor, the same pattern will be replicated and same areas will be increased and same area will be the proportion of the areas of the wall, the windows and the fenestrations and the glazings will be proportionally increased, and I have to divide that by proportional increment of the area. So, if I take the another sandwich, another floor, my total envelope area will be 350 plus 350, so 700, and everything will be increased proportionally, and again I will come down to the same value of 8.35. So, if all the 5 floors are of similar in nature from the elevation point of view, or your the envelope parameter point of view, the geometry of the envelope parameter or the material parameter from that point of view. So, it is the good to have only calculate only for the one floor, and that will be remain as your whole floor, whole building the RETV value. So, next will be, I have just a small analysis. So, we have suppose we have started with this problem the last class or the last lecture 22, east west 2200 and the north and south in 400 meter square of the facet area, and if this is the window areas and the wall area like 40 and 160 for the east and west, 80 and 320 for the south and west, south and north. So, and if these are the window to wall ratio 20%, U value of the wall, window, SHGC etc., PF 0.5. So, based on that, how the change of orientation and how the change of latitude will going to work, let us see. So, this is the first table what in the Excel sheet I have calculated based on those values, and these values are, if you see, these values are from the climate zone of hot and dry, and I got the value as 16.8. 16.8 is something like this. So, it is going to have 16.8. Now, if I just change the orientation, that means if the north is now 200 and east is now 400, just change the orientation, south is again 200 now, just change the orientation, everything remains same. So, you see it is going to change its value. Now, if instead of the this is 6.6 is your hot and dry, see I have highlighted this one, hot and dry and composite both are same. So, if I go for the temperate climate, suppose if I take this value now, this value now if I copy this and if I paste it over here for the temperate climate. So, you see it is drastically reduced to 11.9. So, the material of your choice basket may not fit for the hot and dry and the composite climate, but it is always going to fit for the temperate climate. Let us see this particular value whether it is suitable for the warm and humid climate or not. So, I have to change this particular table values, the table 2, the parameters. No, it is not going to suit because it is again exceeding 15 or so. So, by a slight amount 1.3 amount. So, you have to redesign, the result is redesign because it is more than 15. So, like that we can do this, and suppose in this particular temperate, or if I just undo this one, if I go back to temperate climate which is 11.9, and if I just change the orientation, then again if I say the north is the higher length side and east and west are smaller length, and this is 400 and this is again 200. So, 11.9 will now change to the 10.7. So, again there is a further change. So, change of orientation is going to be a factor, and the change of climate definitely is going to be a factor. So, this is we have seen this is for the hot and dry climate long wall in the north and south. If I go to the next calculation, maybe the same, it is hot and dry with the long wall east and west, it is 18.8. So, it is always good to put the long wall in the north and south, that we understand from our climatological principles, but here also it is suggested the same. And we see how to operate this particular Excel sheet. I will send the Excel sheet to you through our forum, and you can ask for our technical teaching assistants will help you for that. And these are the small table I have the place that for the change of orientation and also the change of the latitude. So, for hot and dry, if you see the first two lines, for the change of latitude does not make any much changes. Warm humid also does not make any changes, even the temperate climate does not make any kind of such a change, big change, but there is a change in between the hot and dry, which is almost like 16 and 18.8, drastically come down to 14.6 and 16.3, and then further go down to almost about 10 and 11 or 12 kind of a thing. So, that is the much more effect in the change of climate, and also the long wall, whether it is in the north south direction or the east west direction, there is a around 1 to 1.5 arbitrary value changes are there. So, we have witnessed that one. This has been calculated based on the whatever data we have started with, that 400 and 200 with 20% of the WWR and those material properties, using that Excel sheet, just changing the orientations and the values of the orientation factor and other values based on your latitudinal latitude positions of the location. So, this particular lecture concludes with a stepwise demonstration of RETV for a apartment building, and we see how the parameter changes with the latitude and the orientation. Thank you very much.